6 plus 2. So it might look like this. 0, 1, 2, 3, 4, 5, 6, 7, 8. Starting at 0, 6 is where we have plus 2. Obviously, you know the answer is 8, right? Or we might have something like example 1, and your book example is available to you. I'm going to do a different example 1. And it's going to look something like this. Remember, back in elementary school, you probably wouldn't have seen something like this, but what we learned when we are subtracting, it's the same thing as adding the opposite. You guys remember that? So, most of you might already know this answer, but let's go for sake of argument. If I have an addition problem, I always start at 0, go to the first number, which is 2. Okay? What am I going to do with that 2? Well, I am going to add a negative 4 to it, which means I'm going to go left 4 spots, which lands me there. This visual representation, starting at 0, represents 2 and negative 4, and the end result is a negative 2. Okay? So far, so good on that? Or maybe I might give you a couple more like this. You might already know the answer, okay? But in case you don't, starting at 0, pause at the first number, which is negative 2. What am I doing with that negative 2? I am giving that negative 2 an additional negative 5. The end result, Jay, close that door for me, would you, buddy, is a negative 7. Okay? And it doesn't matter how big the numbers are, you can perform this technique. Now, I'm going to show you a quick shorthand version of the graph, though, for this next one. I'm not sure I'll even be able to do that, will I? I'll have to just make it work. Instead of starting at 0 and drawing it, a lot of people will just start at the number that's the first number. I'm not going to have enough room. 8, 6, 4, 2, 0. Negative 2, negative 4, negative 6, negative 8. That'll do it. All right. So the shorthand technique is you don't start at that 0 and go to the 16. You just start at the 16 and you go back 1, 2, 3, 4, 5, 6, 7, 8, 9 spaces. Okay, that's the shorthand version, but I prefer if you start at 0, go to that first number, and then do what the second number tells you to do. Okay, that's how I would recommend you do it. If you have an addition problem and you add 0, the identity properties of addition states that any number plus 0 is still the same number. Okay, and there isn't really any examples on this, but I'm going to give you some. Okay, 6 plus 0, still 6. And on a number line, 0, 6, that's it. You add 0 to it. There's nothing more you can add. 6 plus 0 is still 6. Remember, I'm starting at the 0, going to the first number, moving as many positions as I'm being told. Not told to move at all, my answer is still 6. Property of opposites. states that for any number, if I add its opposite, the answer is 0. Okay, I'm going to give you some samples of that. -3 plus 3. We know that's going to be 0. How do I know that? 0, -3. If I go back 3 spaces and then I add 3 more spaces, I end up right back where I started, didn't I? Using what we know about the number line. And I can do that with 57 other numbers, right? But I'm not going to do that. I'm going to go ahead and turn the page here. The property of opposites of a sum state that if you are adding numbers together, like say a -8 plus a -2, then the end result is going to be the opposite of whatever the sum of 8 and 2 was. Okay? What I've always done with you guys is I've just said when you're adding together the same sign, just add them and keep the same sign, right? 8 and 2 is 10. This is a negative. Okay? 8 and 2 is 10. Holy macaroni. All of a sudden, why are these popping up? They're not supposed to do that when I'm in a completely other thing. Okay, figure that out. Okay. Property of opposites of a sum, or -6 plus -2 is the same thing as saying the opposite of the sum of 6 and 2, which you already know is a -8. But what this does is it describes it for you. Okay, and I'll show you a couple of examples like that. But again, you're probably already doing it by simply adding together stuff and keeping the sign. -3 plus -2 is the same thing as the opposite of whatever 3 and 2 is, which is -5. Okay. Yeah, I don't even like the other example, so we're going to stick with that. Okay? In those 8 minutes, folks, that is everything I have for you.